X5G, we're now just applying and solving. So you need to know your log rules and exponential rules, maybe a bit of log properties in case there's inequalities. Otherwise, let's solve this one. Here we go. We've got log base e of 7, take away x, log e of 14 is equal to 1. Common mistake. Log rule number 2, if you subtract, you divide. So then most students will then write log e 7 on 14. Wrong. Why? Because there's an x there. Very good. So in this case here, you can't do that if that's what you were thinking, and then you simplified that to a half. That is wrong. Okay, you can't do that yet. You have to get rid of that x right here. So how do we get rid of that x? How can we manipulate it? Very good. That's rule number 3. So log rule number 3, you can then change it to a power. Changes the expression to or equation to log e of 7. Take away log e of 14 to the power of x is equal to 1. Now it's okay. Now it's okay to do log rule number 2. And log rule number 2 says log of m, take away log of n, is the same thing as log of m divided by log of n. All right, cool. Guide me to the next step. So now we've combined it. We simplified the logs. What do we do next from here? Can I please have, let's go with Vibha. What would you do next? That's true. So what he's done is that's a log base e. So inverse of log is exponential. So we do e to the power of the left and e to the power of whatever's on the right. So essentially what I'm saying is you're doing e to the power of log e of 7 over 14 to the power of x equals e to the power of 1. And the nice thing is that these two cancel out. They're inverses. So that's what Vibha was saying. Vibha was saying that it's 7 over 14 to the power of x is equal to e. Great. Our goal is still to find x. So we now got x in the denominator, but it's also a power as well. So it's a bit tricky there. What is the next step? Let's go with Anne. What would you do? Good. So you times both sides because it's currently in the denominator. So if you times both sides, 14 to the power of x. 14 to the power of x divided by 14 to the power of x cancels out, and you end up with 7 equals e multiplied to 14 to the power of x. Now, at least it's not in a fraction. That's good. We're getting somewhere. Oh, you guys can't even see. Oh, did it freeze? Oh, that's funny. Well, we'll just have to reconnect again. Well, whilst this is waiting to connect, finish off the problem if you can, and I'll write up the solutions as this is connecting. Divide e on both sides, and then I'll get 14 to the x. Oh, it's coming back. Cool. All right, so from here, if you understood what we just did there, we move the 14x across, and then from here, I then move the e across, so I divide both sides by e. And you got 7 on e is equal to 14 to the power of x. And finally, now you can get 2 different answers here, depending on how you want to write it. You can work it direct. Since you got a CAS calculator, you can do log base 14. Back in the days, we'd have to do log base 10 or e, so we had to do one of those two. You guys can choose whatever you want. Okay, so I'm going to take the route of, let's say you did log base 10 or e, then I would have done this, log base 10 of the left, log base 10 of the right. Using rule number 3, we can bring the x to the front, and you get x times log base 10 of 14. This is log base 10 of 7 on e. And to get x by itself, I just got to divide both sides by log 10 of 14. That way, on my scientific calculator back then, what I would have typed is log base 10 of 7 over Euler's number divided by log 10 of 14, and I'd get exactly the same answer had you done it this way. If you had done log base 14 on both sides, then you would have got log base 14 of 14 to the power of x, and the nice thing is these two will cancel out, and you literally would just get x equals log base 14 of 7 on e. But calculators back then couldn't do that, but if you did that on your CAS now, you got two answers. You could either have it this form, which should be equivalent to this form. Okay, so 5G is literally practicing your exponential skills there. Now the next question, if you've forgotten without me showing you, what is the trick to this question? When you see 5 to the power of 2x minus 4 times 5 to the power of x minus 5, what should you be thinking about? Can I please have Zach? What kind of problem do you have to convert this to?
It's quadratic.
Very good. That's a typical exam question, exam 1 type question. So it means in your SAC, if I were to test you, I'd put something like that in as well. I could do that for a log as well, but idea is to convert or find common parts where you can change it to a quadratic, and that 5 to the 2x is the same thing as writing 5 to the power of x squared. So it might make your life easier if you just called it a, b, or c. I just called t equals 5 to the x. I rewrote that 5 to the 2x over here. There's your 5 to the x's, and so if you replace it, each one, instead of 5 to the 2x, it's now t squared minus 4 times, instead of 5 to the x again, I'll call it 4t, and then minus 5, and you end up with a quadratic. That is a very typical problem, and there's a few in your year 12, and there was only maybe a handful in your year 11 textbook. Factorize and solve, so null factor law, you get t equals -1 or 5, but that means since t is equal to 5 to the x, you get two possibilities here, and you have to reject one of them. 5 to the x can never equal to -1. If you think about the exponential graph, it doesn't go below the x-axis, so x can't be -1, or 5 to the x can never equal to -1. Whereas on the right-hand side, 5 to the x equals 5. Yes, we know x equals 1, so hence one answer. So there's a typical 3 mark. If you got up to this point, and you might have then went to this point, and you could have both answers if you did log, you get 2 marks. Not until you actually write this bit, justifying that x is undefined. That's when you get your 3 marks. Okay. Well done. And now let's see if you can do it. Here's your next one. Turn over the page. This is a VCAR 2025, exam 1. Oh, sorry, 2015. So 11 years ago, this was considered hard. This is no longer hard. This is the preliminary basis that you walk in. This used to be 3 marks. Might still be 3 marks if they want to be generous with you this year. If you happen to have it, you should be thanking your lucky stars that they gave this to you. Because that's 3 marks out of 40, which is a lot in my mind to do something like that. It's a textbook question. Here we go. I'm going to pause the video. And is it recording? Yes, it is. Here is our answers. 3, 2, 1. Can I get a show of hands who got the same answer as me? Yes. Log base e of 8 on 3. Cool. Good. Excellent. Make sure to write undefined somewhere so that you get your 3 marks. But most of you should have at least gotten to this bit. A equals 8 on 3 and a equals -1. All I did was, again, just times them all by e to the t. Maybe this was the only step. If fractions is your weakness, then that may have been the area to improve on. All right. Let's have a look at the last example I'm doing today. Example 27. What is a common mistake? Now, if it's a CAS, you can type it in your CAS. It'll tell you the answer. I'm going to do the wrong thing. I want you to spot out where I went wrong. Here we go. We got 0.7 to the power of x. It's greater than or equal to 0.3. And I'm going to pretend that we don't have the CAS calculators the way you guys do. I'm going to use base 10 and base e only. So here we go. I go log base 10 on the left, log base 10 on the right. And that gives me now log base 10 of 0.7 to the power of x is greater than or equal to log base 10 of 0.3. So far, so good. And then I say rule number 3, bring down the x. I get x times log base 10 of 0.7 is greater than or equal to log base 10 of 0.3. And my goal is to solve for x, or the inequality. So to get x by itself, I got to divide both sides by log base 10 of 0.7, like this. And therefore, my answer should be x is greater than or equal to log base 10 of 0.3 divided by log base 10 of 0.7. Where did I go wrong? So I guided you through my steps. Whatever I did to one side, I did to the other. I balanced the equation, but I did something wrong already. Where's the error? Donis. Say it again. The x has to be divided by log 10.7. Yeah, so I divided this side by log 10 of 0.7, and then I divided this side by log 10 of 0.7. X doesn't have to be, actually. Only because if it's addition, yes, but because it's times, it's okay. Yeah. Good try, though. Anyone else? River. Beautiful. That's the one that catches students right there. Right here, because often that students don't see the number, they don't get it. But that's why I'm saying, think about the graph. See, log base 10 of x, if I asked you to sketch log 10 of x right now, whoops. If I said y equals log base 10 of x, you would tell me it looks something like this. What's the y-intercept? I mean, x-intercept. 1. So that means log 10 of 10, that's at 1, 0. Sorry. Whatever. Sorry, 10. Sorry. It gives you the value of 1, 0. But my point is, right there, do you see any value that's going to be less than 1? Well, technically less than 10, because it has to be log 10 of 10 to make it 1. As soon as it's less than that 1 value, that's a problem. Okay? Because less than 10 to the power of what gives you 1? We know that 10 to the power of 0 gives you 1. So that means this one, as soon as it's less than 1, less than 1, log 10 of 0.7 is going to be a negative number. But what happens when you divide by a negative number in an inequality? You're going to flip the signs. Because logically, if I got negative 2x is greater than 1, when you divide both sides by negative 2, x then swaps. And the reason for the swapping makes a lot of sense, because if you just think about numbers, 3 is greater than 2, which is true, but as soon as you put a negative in front of 1, you put a negative on the other side, that doesn't make sense now. Negative 3 is not bigger than negative 2. The only way that's going to be true, you flip the signs. And logic to that is because of the reflection on the x-axis. That's why. So the little trick there that students tend to miss is that when they divide it algebraically, nothing was wrong there. It's understanding this value. Log 10 of 0.7 does not equal positive value, just like this one is not a positive value either. But because you're dividing it, the answer should have been this way. It should be less than or equal to. Okay, so if you did it on a CAS, you wouldn't have had that problem. But if you did it by hand, that's possible problem. So just be wary when you're doing logs. Check, is x less than or equal to 1. Okay, so just think about your graph on logarithmic graphs like that, or you can think about exponential graphs as well, like that, and then you can understand anything less than that 1 value. Okay. All right, team. So that was another catch on what could be a good one to look at. The last one, I'll leave the solutions here, but I want you to have a go before you look at my solutions. That's a VCAR 2014, exam 1, 3 marks again. So there must be a justification at some point, or they're looking for some, I think it's a fraction thing. Yeah, that students tend to make a mistake on. Okay. But it does tell you x greater than 0. So that's probably one of the hints as you're solving it. Okay. I'm going to stop the video there.